Hey, welcome back, folks. We are into chapter 15. We are looking today at a constant acceleration example. And the situation is that at time 0, wheel A is rotating clockwise at 450 revolutions per minute. And wheel B is not moving. They come into contact, this slides over, they make contact, and there is 6 seconds of slipping, during which both of the wheels undergo a constant acceleration. And we are told that at t equals 6 seconds, omega A is 140 RPMs in the clockwise direction, and we are asked to find the acceleration of both wheels. So let's get to it. First of all, remember from a few videos ago, our constant acceleration equations are, let's see, we'll say equations okay, and omega equals omega naught plus a t. Okay, and I think that's the only one we're going to need. We can come back if we need another one. So let's see, we've got these in terms of RPMs. That doesn't really help. So let's see, omega naught A equals 450 R, 450 RPM. We need that in radians per second. Well, let's see, there are 2 pi radians per revolution, so revolutions on top, we need radians on top, so let's do this. We'll say times 2 pi radians, and then 60 seconds per minute, which should get us there. And that gives us, let's see, 450 times 2 pi divided by 60. And I get 47.124. So 47.124 radians per second. Okay, and that is in the clockwise direction. And similarly, omega A is 140 RPM. Again, 2 pi divided by 60. And that is going to give us 14.661 radians per second. Okay, so we have omega naught, we have omega, all we need is alpha, so we should be able to get that one done pretty quick, right? So let's see, omega is this, so 14 point, I hate doing it that way, let's do it algebraically first. Omega naught plus alpha t, so I subtract that from both sides, gives me that. If I divide by t, then that gives me that. So on the other side, I'll actually do the thing. So 47, right, sorry, 14.661 minus 47.124 divided by 6, and that is alpha A. So alpha A, I can do a better alpha than that, right? alpha A is equal to, let's find out, 14.661 minus 47.124 divided by 6 gives us minus 5.41 radians per second squared. Okay, so the reason that I chose this problem, let me just verify that I got that right in my notes. Oh, and notice that if we're going to say minus, then we need to define this something as the positive direction, right? So we need to say clockwise is positive. All right. So the reason that I chose this problem is to consider what it means when they don't tell us that what the end velocity of B is, right? So we know that it starts at 0, but it ends at something. And so if we just look at it, they're in contact, okay? And let's see, A is rotating this way. This is A, which means that B has to be rotating this way, right? So B is moving in the anti-clockwise direction. So if you can imagine pulling a piece of paper or something through here, then it would come through with some velocity, right? And we've defined the velocity. So this is the tangential velocity, and that comes from the arc length, right? So that is r times theta dot, which is r omega, right? And that is the general definition. And so what that means is that well, first and foremost, the v of A has to be the same as the v of B, right? So what that allows us to do is to say Ra omega A equals Rb omega B, right? And you know, we're not going to worry about the directions of them, but the magnitudes for sure have to be the same. So if we want the magnitude of omega B, then we just divide the radius of B, and we end up with that. So what is that? Well, let's see. That is 3/5, right? So 3/5 of this, and I'm just going to keep the value here. Wait, I'm sorry, that is, no, it's not that. It's of omega, and omega is 14.44, or excuse me, 14.661. 14.661. Okay, and that gives us an omega B. Let's see, 3/5 of 14.661 is what? It is 8.7966. So let's just go with 8.8. 8.8 radians per second. And by inspection, we see that it's going this way. Okay, well, we can reuse this relationship, right? So alpha B, which this is, by the way, this is why I always do the algebra first. It's just faster. Equals omega minus omega naught over t. Well, let's see. There was no omega naught. We started at 0. So this is 8.8 divided by 6. Well, that's not hard. Unless you try to do it in your head, right? So I get 1.466 radians per second squared in the positive direction. And I'm just going to rewrite this so that when I circle it like that, it looks tidy. Alright, so let's make sure I get it right. Did I get it right? I think so. It matches my notes. Okay, well, these are pretty straightforward. This is a pretty simple concept, but if you haven't seen it, it can be, a little bit disorienting. And that's it for me. So I will see you in the next video.